righty. So I was going to start by talking a little bit about the survey that I ran in Slack. I think Jose and Vince, I think I saw both of you responded to this. Hey, Jess.
Hello.
Just getting started. Talking about the brief survey that I ran in Slack. Basically, I asked 3 questions. The first was just kind of a check-in on how folks were finding the study groups. For the most part here, folks seem to be getting some value out of either the live calls or the recap videos. There were a fair amount of folks that responded that would like to attend the live study group, but the time doesn't really work. Not sure exactly what to do with that, but if folks that are on this call have this understanding there's a sampling bias here for the folks that made it, but if folks have other suggestions for time, I'm totally open to that and may bring that up on the in the Slack channel at some point. And then Vince and I kind of talked a little bit about his Vince, you were the number 4 respondee.
Okay.
At the end of the video and didn't find it all that helpful. Like I said in the question, no hard feelings. You and I have been going back and forth about the course quite a bit, and I appreciate your feedback. And I've relayed some of that to IBM as well. We've got another conversation scheduled about just kind of general observations about the course so far. But all that having been said, I guess the next question was kind of where folks are, and maybe we can just have everyone kind of talk about where they are. I know, James, you're just getting started, so probably working on course 1.
Right.
Where's everybody else? Jose, you're pretty caught up, right?
Yeah, I'm pretty caught up. I'm on course 2, second week, so yeah, caught up.
Okay.
Cool,
Course 2, first week for me.
Okay. Jess?
Yep, I'm pretty much caught up.
Okay. All right, cool. And then the last question that I asked was just trying to level set on what aspects of the study group folks find most valuable. And this was interesting for me. In the past sessions, I've spent probably most of the time recapping the course materials, and nobody said that was interesting. Whereas the kind of open discussion where folks would share experiences was kind of the top item of interest. Second to that was kind of a walkthrough of projects and case studies, and then I propose maybe finding guests to come in and, share their experiences. That was kind of interesting to some folks. The catch-up sessions, were as interesting to folks, and kind of the Q&A. So as a result of that, basically my plan is to tone down the recap and try to emphasize the project walkthroughs and peer discussion more. We should have a good session, as the folks that are on thus far have been great contributors to our discussion. Thank you all for that. And I'll continue doing these catch-up sessions so that we can kind of bring new folks into the fold as we get deeper and deeper into the sequence. Any thoughts or comments on the study group so far generally, or the observations from this survey? Granted, it is a very small sample size, very small number of respondents.
Yeah, I'm surprised the recaps weren't rated a little more highly. I wonder if they didn't take the top spot for the people who responded, but maybe they were in the second spot.
Good point.
Yeah, I think to add to what Jess just said, I agree that some of the recap, especially like some of the meteor stuff, like even like this week too, there's some things on like the uh, I don't know, some things on statistical inference or some things like that where I think it would be helpful to recap together. Same last week, there's a few things that were a little meaty that was helpful to discuss. So maybe like not covering every piece in the recap, but some pieces is still helpful for sure.
Okay. Yeah, we'll see how it plays out this time. I think, well, you'll see as I get into it, but I'm kind of going through it using the existing course materials and some of the supplementary examples and kind of using that as a basis for discussion of those items as opposed to kind of slides that summarize the materials. But we'll see, and you let me know what you think. Hey, Pradeep, welcome. Any other thoughts or comments or takeaways on this? All right, cool. So we are this week finishing up course 2, week 2. The focus of this week is on estimation and null hypothesis testing. So the learning objectives for the week were fourfold. The first was creating a simple dashboard in Watson Studio, or learning how to do that. Learning how to employ common distributions to answer questions about event probabilities. This is the statistical inference piece. Applying null hypothesis testing as an investigative tool using Python, and explaining methods for dealing with multiple testing. So the first one of these is the Watson Studio dashboard example. Did folks go through that one?
I'll admit I've been working in Jupyter notebooks all the time. I haven't done much in Watson, so that's the one thing I have time. But it'd be helpful to learn from what you guys saw. Sorry, guys.
Yeah, one thing that would stop you out of the gate with this one is that the data file that they had distributed there was like the Avail Streams data file that we've used in the past, and is really not what you're supposed to be working with here. So let's see. The scenario is that you are you're basically trying to do some kind of exploratory data analysis on this data set that has, customer IDs and whether they're subscribed, what tier of a free trial they're in, some demographic information, etc. And the actual data set that you need to use is not this Avail Streams data set, but it is the Kaggle Titanic data set. So that basically the way this works is, I think on this tab's where you have your data sets, and I can show a preview of this data set here. Basically, customer ID, I think, is like a record number in this data set. Is subscribed is the a renamed, did they survive the Titanic crash? Free tier trial, I forget what the original field was. And then these are all the Titanic passengers and their demographic information. There's this SIB SP field. Oh, no, never mind that. There's a market, which I forget what this one was originally in the Titanic, but they say it here. You basically replace the kind of fields in the Titanic data set with the appropriate fields here. And then you can load it into Watson Studio as a data asset. And then this Watson Studio dashboards thing, it is actually IBM acquired this company Cognos a long time ago, the business intelligence tool, and that's basically what this is. It's a cloud version of Cognos. And so you're basically creating reports. They've got 4 sets of reports that you would create in this. I did a couple of them. To be honest, it's kind of tedious, but the basic idea is for this third tab, you want to look at, say, number of customers in each of the free trial tiers. So you can go to your visualization elements. There's a column chart that you can just add to your dashboard. For the bars, we want to look at the free trial tier, and the length of those bars is going to be the number of customers, and it's got some smart defaults here, but in this case, you're doing account distinct on customer ID. And this is your dashboard, and then you can, when you're done editing it, you can put it on your dashboard. You can add a text thing, customer versus free trial tier. And that's basically how this works. And in this particular case, the data comes from, again, that CSV file. Presumably there are other data connections you could use so that this information stays up to date, or maybe you just update your CSV file. All of that is kind of outside of the scope of this module. They're really just trying to show us how to set up these dashboards in this Watson Studio. Any questions on this stuff?
Yeah, could you go over again the idea of how you're swapping Titanic? And I didn't quite follow what you were doing there.
Oh, yeah, absolutely. So the data set here, if you go to Kaggle Titanic, if you just Google Kaggle Titanic, you'll get the
right, that data set.
Kaggle competition, and you can download this data set.
Mm-hmm.
And
then you're using that data, but you're renaming some of them to
that's right. When you
avail.
open up this data set, this is the train.csv file. So there's a passenger ID. This becomes your customer ID.
Okay.
There's survived, and that's like is subscribed. There's passenger class, that becomes your tier free trial. And then embarked over here becomes your market. I think those are the main changes.
All right, cool.
And then once you do that, you can let's see, save that. So okay, we'll leave. You go to your projects. You click Add to Project, and you can say you want to create a dashboard. Then you can name your dashboard. Oh, what do I need to do? If you don't already have an embedded dashboard service, it will prompt you to create one or select one, and then you create it. And they've got these different templates. This tabbed freeform one is the one that they seem to want you to use for the tutorial. And then you have to connect it to some data. And so I guess this is what we were talking about earlier. You can, presumably you can set up some live connection to some data source. But for our purposes, this is the trained CSV that I uploaded.
Okay.
Navigate and you see these are the various fields. That makes sense?
Yeah, it's just like, the initial step there of which database we were using and renaming it, I was a little confused on. So now that's definitely clear.
Yeah. So that is the Watson Studio dashboard example. You know, I did a few of these just because I was curious about how it worked. I wouldn't necessarily spend a bunch of time on it. In fact, they make the point in the previous weeks that, you know, they distinguish between dashboards and notebooks, and emphasize how in the exploratory data analysis phase that we're supposed to be in the course, right? The real focus is on kind of doing quick and dirty analysis and not, you know, worrying about setting up complex, long-lived dashboards. And so I think this was, you know, just to give you a sense for, you know, what those might look like. But, you know, I don't know that we need to spend a ton of time on all of the different examples that all of the different dashboard widgets that they want you to set up. So the next set of material is on hypothesis testing and statistical inference and p-hacking and all of that stuff, which I think is, Jose, as you mentioned, like there's some really, really meaty stuff here. So, oops. I really recommend this video. This is the main, you know, there are a bunch of readings in the estimation and hypothesis testing, but if you dig into this hypothesis testing video, there's a bunch of interesting material in here. Have you all, or who's gone through this one? Anyone?
Yep, I have.
Yep.
All right, cool. So if this one is like, there's no talking head here. It's all kind of dense material and kind of notebooks. I went ahead and copied over some of the notebook here. Basically what this one is talking about is, hey, the scenario they set up is, you know, in your same role as an Avail data scientist, you are tasked to work with a DevOps team that is looking to allocate compute resources, and they have some data set of the of compute utilization, let's say, and we're simulating that data set via a beta distribution. So the beta distribution, the idea with the beta distribution is that, you know, this is our data, and then the main focus of the discussion in the video and this notebook is here. It's this inference. So, you know, we've got some data. We typically don't know the exact distribution that generated that data, but we can try to fit it to, for example, a normal distribution. And then we want to do some, you know, some testing to see how good a fit that is. That's basically a big part of the discussion in this section. And I'm curious what you all thought about the video and how you've seen this play out in the work that you do. I personally have found the statistical conversation to be, you know, it's been the most challenging stuff for me thus far. Like I've had to, you know, read up a lot of like SciPy stats, you know, distribution information and stuff like that. Where are the rest of you in terms of your statistical, you know, background and familiarity with this stuff?
Well, this is Jess, and I'd say I'm actually pretty familiar with this, coming from academia, and it's really, you know, widely used there, and coming actually out of business schools with quality and process analysis, and then out of social and health sciences. So, I mean, it's been pretty prevalent, you know, kind of in my background, and it even still is, because when I present data science work, you know, that's often what the audience is most familiar with. So they really want to see it in those terms. And so sometimes I'll even kind of use some of that language when I've used other methods that aren't, you know, really as much even about the statistics, but it's sort of like the audience is expecting that.
Interesting. And what were your key takeaways from this section of the course? You know, were there things that you thought that they, you know, either did a good job describing, or that, you know, you thought could be described better, you know, based on ways that you've seen it done before?
Yeah, I mean, it all seemed fine. You know, it seemed like kind of what I would have expected it to be. I think that, you know, with statistics, it makes more sense the more kind of examples or use cases or scenarios that you can, you know, kind of work with, rather than just getting the methods themselves or the theories or the math of the methods themselves. I think that a really good resource for kind of, you know, learning sort of what's in the material here, but then thinking about it in kind of a deeper way, is to look at some of the materials from Cassie Korzakova of Google, because she's often taking that and then really talking about it in a really applied manner. And I think that's super helpful. Yeah. Her last name is going to start with a K. So that might, and I think her title is Chief Decision Scientist at Google.
Mm.
And she's got some really good, you know, she frequently is talking about statistics and, you know, and really just kind of plain English language, entertaining examples, but usually pretty thought-provoking. So if you were new to statistics, you'd definitely be learning things from her blog posts and her short videos, which are often geared for those at Google who are coming from more the software engineering side and trying to pick up, you know, something about statistics. But then I think even if you're pretty advanced with your knowledge of statistics, the ideas that she brings up around them and the application side are often kind of illuminating.
Okay, if you can help us find that.
That's helpful. I found her. It's Cassie Kozyrkov, a Kozyyrkov.
Kozyyrkov. Oh, that did come up. That was it.
Yeah.
I'm really surprised that didn't pop up no matter how you typed it, because she's pretty popular.
Took me a little.
And
See, this shows me, right? I'm sort of, everybody knows about Cassie Korzakova. No. Why would they?
so it looks like she does some writing on towards data science. So are these the kinds of things that you're referring to? Some of her blog posts?
Yes, yeah.
Okay.
So she talks a lot about, you know, kind of AI ML, but then she's got a pretty good dose of interesting ideas about statistics, also the kind of the different roles like data scientist, data analyst, and why it matters, and so it's interesting things.
Nice. Awesome. Thanks.
Yeah, Jess, thanks. That's really helpful, because I think my reactions to this video was a little different. I think it was very helpful and very meaty, but for me, I spend most of my time in the business world, and it's actually very rare that
Right, right.
level of data science. But I think a lot of right, I think everything's moving in this direction where this level of statistical analysis really matters, and part of the reason I decided to take this course. So I think it was so my reaction is like, and knowing about Cassie Culture Club will be really helpful because I'm going to spend some time on her website. Just
Yeah,
digging.
she's great. The way that she talks about the perspective she comes through, I think is just invaluable. And I think, as I think about in terms of business applications in most environments, I think it is actually kind of limited, this sort of like pure statistical framework. I think I've seen it, sometimes with A/B testing. But even then, I don't know that, folks are really, holding true to the statistical side of A/B testing.
Yeah, I think I've seen it in A/B testing. I've seen it in a few other product tests or surveys or how to market to customers. I've seen a little bit of
Mm-hmm.
statistics in that sense. But I think it's, if you ask me my personal opinion, I think it's kind of sometimes a mistake of the business world where the business world will be too impatient to do this analysis all the way through. They'll say, okay, let's do a quick halfway A/B test. That makes sense. Let's just run with this. And
Right.
that's what I've seen. But I think more and more people are going to apply these analyses across areas beyond where they've been applied in the past. And so I think this video was helpful, and it certainly gave me, reminded me, like you said, Sam, I need to go back and find my statistics books from my previous classes and start digging into them again because they've been a while.
Mm-hmm. Yeah, there was, I think they may have linked off to a Khan Academy course somewhere in this session. I went to that, and that may be an interesting resource, but it started, it linked you off to the beginning, and it started with some pretty basic stuff. But finding, I think for a lot of this, for me, what's important is, or what's missing for me is like really having, I don't do it frequently enough to have like all of the distributions like at my fingertips and know kind of the general shape of this one versus the general shape of that one. And I think, similarly with like matplotlib and some of these other things, having all of the plots, at your disposal, at least knowing that they exist. If I know that it exists, then I can Google it and, figure out how to get to it. But, my experience finding Cassie Korzakova notwithstanding. But I think a lot of it is just kind of knowing the landscape, and, finding good resources for that can be difficult.
I went ahead and put a link to her YouTube playlist about statistical thinking.
Ah. Oh, that looks really interesting.
Just nice short bites for the most part.
Cool. All right, yeah, I'll definitely spend some time on that one. Thank you.
Yeah, I'll be interested to see next time what you think. She has an interesting manner how she presents things, really different from, most of the time when stats is being talked about. She has a particular sense of humor.
Okay. Generally, I like that. So in this one, Jose, did you have any particular questions or things that you wanted to talk through or drill into in this particular section?
No, I don't think anything in particular. Just like you've done previously, a helpful overview, and the discussion we're having now is fine. Nothing, no particular questions.
Okay. Yeah, I would recommend, or at least what was helpful for me was, and I could actually put this up on GitHub or something like that, but I went through and kind of pulled the code that for whatever reason is only shown here in these pictures, and put it in a notebook, and then you can kind of play with the examples and see kind of play with the examples of fitting the distribution, the Gaussian, to the different beta distributions. And again, for me, it was part being able to play with it, but also a little bit kind of tuning my muscle memory around, setting up plots in Matplotlib and, creating random variables and all that kind of stuff with these different distributions. So I also did something similar for the next point that they raised. So in this section, we talk about the general idea of hypothesis testing, specifically being that, when you're when you want to explore an idea or propose that there's some relationship in your data, the way that you do that is you establish a null hypothesis. The null hypothesis being the instance when that is not the case, and then you set up your statistical tests to determine if there's evidence that your null hypothesis is wrong, and that's where your p-value comes in. The p-value is the probability that essentially the probability that you would not see. It's actually probably better to say this in the context of a specific example, but the p-value ends up being the probability that the statistical properties that you're observing are, that you would see them in a wild, I guess, is kind of a high-level way of putting it. And maybe, Jess, you can help me out with your statistical knowledge here if you want to explain p-value.
Yeah, so you really are going to think about it in terms of, let's think like an intervention, right? And so one example coming out of health sciences is whether a drug is effective or not.
Okay.
And so you would say, so the null hypothesis is like, well, yeah, this drug is probably not effective, right? Until proven otherwise, we're going to say it's not effective. So that's your null hypothesis, is that things are, pretty much as they would be out in the world with or without this drug. And then you do your blind randomized controlled trial, the gold standard, and you get your results and you look at them, and then you find that, wow, it actually seems like something is really different, for the group that took this drug. So then we say, okay, so it seems like taking this drug does make a difference, and we wouldn't be seeing these results. We'd be seeing these results, and by random chance, is there's a very slim chance that we would just be seeing these if it wasn't due to the drug, right? Because in statistics, it's always you're taking into account that there could be random chance. Maybe you just happen to get a bunch of people in that particular group that it wasn't the medication, it was some other factor that you didn't think of, right? So it could have been just up to random chance. So the p-value is the threshold that's letting you, that you've set before you even started. You said, I need the results to be so rare out in just random chance world for this to happen by happenstance. And the p-value is that threshold, right? So you would say, and then the flip side of it is it is also your confidence level. So at p.05, you would say, at a confidence level of, p.05, I'm 95% confident that these results could not happen just by random chance.
In the lecture, they talked about, they distinguished the p-value, the probability that these things are happening by random chance, and the threshold, which they talk about as alpha. Did I get that correct?
Yeah, so in the formula, it's alpha, but you can really think of them as so linked that you can speak about them kind of very similarly, so that if you have that, p 0.05, then what you'll really be saying, because you won't be going around talking about a p-value, you'll be going around talking about how confident you are in the results. So you'll say, we're 95% confident that the positive results we saw in the group that took the drug were from the drug, not some other random chancy thing. And then, if it's something really serious, you want to be even more sure. So you want to be like 97% sure, 99% sure. And so that's where you are using kind of standard like p 0.05, p 0.03, p 0.01.
And most of the time when I've seen p-values, it's the 0.05. Is that the standard for
So
typical data science things, or?
yeah, so out in the world, that is the absolute norm. I think, you'll see it be at those lower values when it is more something like pharmaceutical research, or, something in the health sciences, or something that, in other words, could be pretty dangerous if you make assumptions that aren't really true, and that really there was some element of either random chance or something that you designed incorrectly about your experiment. So, but usually 0.05 is considered to be a good enough threshold.
Yeah, and in business school and in everything I've done since then, 0.05 has been the threshold used there. But I think Jess is right. For things that have more critical impact, like health-related things or things like that, I think it can certainly be a lower p-value required.
All right, cool. So I think that gets us to, so this is an example that they go through, and the idea here is to explore t-testing. The example scenario that they gave is kind of back in this domain where you're working with your IT group, and you've got these, I forget what the specifics are, but it's like say it's the web page load times for, when your web page is hosted locally versus when it's hosted in the cloud. I think the example they gave is slightly different, but the idea is that you've got these two sets of data, and this is one where they don't give you the notebook, but they have the cells embedded on the page, but you can easily copy it into a notebook. You've got these two sets of data, and then you are applying the t-test to determine the p-value, reflecting the likelihood that the data that you've collected is from the same distribution. Did I get that correct, Jess?
Yep.
All right. So what I did here was just kind of exercising the matplotlib and graph these two sets of data, and the actually in this case the null hypothesis is that there's no difference between the local and the hosted services for stream processing time. So this p-value that's really low says that it's very unlikely that there's no statistical difference between these two streams, and that's reflected here, and you can see that the means are fairly different.
Yeah, I mean, the null hypothesis is always that there's not going to be any difference between your groups, because it's always saying that whatever it is not effective, or it's not helpful, or it has no impact. That, it's just going to be the same as how life is with or without whatever this thing you're testing. So the null hypothesis is always going to be that way, that there's no difference.
Yeah, one thing that I learned here is a little bit of the history of the students' t-test. I thought it was like students as in student, but apparently it was the person who created it used a pseudonym of student. Just a weird, there are lots of links to Wikipedia throughout the course, and that was just a weird kind of thing from the Wikipedia article on that t-test. And so we talk about that, and then there are different versions of the t-test, actually quite a few, but one that they talk about in this context was whether you can assume that the variances are equal or not. And that is a setting in the t-test function, and that will change your value. There were also quite a few other variations on the t-test based on whether, so let me see if I can find that one that's here. Whether you've got one group of scores, whether you can assume that your samples are independent or not. Just any thoughts, or how do you see these different types of tests being used out in the wild?
Well, I can tell you that the error, when people are kind of incorrectly applying statistics, it's often due to this, exactly what we're talking about. So they've done some kind of statistical tests, but they didn't think about, some of these things that you should be thinking about actually up front, right? And so in data science, it's nice because we have the tools that we can, in our EDA, take a look at the distributions and the variances of things, really easily and really visually. And so those things help us pretty quickly narrow down, what we should be doing here. But often folks aren't really, I think, in real life necessarily doing that. So sometimes they'll have, they'll be treating some data as though the samples were independent, but they're actually not. If you were to look into it, you'd see that there's some correlations, some dependencies there, or that, you're doing A/B testing, and what you didn't look into is that one group has a lot more variance in their answers than the other group does. Like you'll see that maybe sometimes with gendered things, men versus women, or older, younger, things like that, that actually there's differences in the variances between the groups. So I'd say that this is a common point of kind of applying stats either incorrectly or not in as ideal a manner as you could to get the best results.
Cool, thank you. So that was the first part of the t-testing, and then there was another example using ANOVA. This is a method that allows you to compare multiple sets of samples, so not just two. In this case, there's a set of local arrivals and then two set of cloud arrivals. We're calculating some summary statistics up front, looking at comparing the global mean with the means for the individual samples, and then running this this one-way ANOVA on all of these sets to get the p-value that, again, refers to this null hypothesis that there's no difference. And once again, the p-value is very small. There's some discussion in the course about the need to correct for multiple tests. This comes up in the case study as well. And there's high-level discussion about a couple of different methods of correcting for multiple tests. The high-level takeaway for me is that when you're doing multiple tests, you need to apply some correction. But outside of linking to the individual papers, they did not really provide any nuance on which of these you might want to do. Jess, I will once again invite you to, if this is something that you've got some experience, comment, you can comment here.
I'll just say that, on topics like this, I'm such an applied thinker that I frequently feel like this is where we just need to have a flow chart and say, if your data is like this or has these characteristics, yes or no? Yes. Okay, great. Does it have this or that? Yes or no? All right, great. Do Bonferroni. If no, then do this other thing. Because I think like in the day-to-day, the knowing the intimate details of the different mathematical methods and why this one versus the other one, it's hard for me to see an instance where that's as important as just knowing do this one or do that one.
Yeah, and for me who doesn't do this day to day, the takeaway is at an even higher level, and that is, if you're doing multiple tests, maybe throw a few of these at it and see if it changes your result. If you're like close to your threshold and you get different results on different sides of the threshold, then maybe you need to look into it more. In these examples, you even after adjusting, you're still below the threshold. So
right. And see, that's the thing, is that's really ultimately all that matters, is do you get below your threshold? So you could get, more refined below your threshold, or, less refined below your threshold, but you're still getting the same answer. And I feel like unless this was something that a person was just so familiar with that they could just look at it and go, oh yeah, that's Bonferroni, I'm going to use that. If you couldn't do that, then by the time you sat and thought about this, you actually could have just run 2 different tests and seen what they gave you. And I think that a lot of the statistical and data visualization tools are now having a lot of this built in, where they're actually, the software is analyzing the data up front. So it's sort of, doing that mental flow chart that I talked about, like kind of like in an auto stats, let's call it, sort of way. And so it's just sort of running the most appropriate test, because anything you could think of, then obviously you could build the software to also detect those patterns and to then use the best approach for your statistical analysis. So I don't know there's a lot of value added, like once you get pretty far down on that flow chart, I don't know that there's as much value added in understanding it as there is kind of at the top. Like, what is a p-value? What are these distributions? How is variance going to impact things? Because I think understanding those things is going to help you understand how to set up, let's say, an A/B test, or how many people to take into it, or how to look about the factors of who you recruit into that, or how you do that. But then when you get down to this level, I do feel like it's a bit of a, run a few things and see what you get, and then come to your, conclusion, which is that this makes a difference or it doesn't make a difference, because that's really what you're trying to get to once you're down to this level of the analysis.
Mm-hmm. Cool. That's super helpful. Thanks.
I think one thing just to add on to that, I mean, I don't do this day to day either, but I'm even just reviewing one of my stats books here from business school right here while we go through this discussion. And I remember learning a bunch of techniques around, you can run different tests. You can also have different approaches for detecting things like multicollinearity, or omitted variable bias, or things like that, where you can estimate the extent of your bias and determine whether, if you run a few different tests and estimating the extent of your bias, one seems to be less biased than the other, then that can be a result that you can go with too. But that's at a high level. I really don't remember the details of it, but just thinking about that too.
Cool. So the next up is the case study. The case study, the scenario here is that we have been asked to help at Avail in optimizing the distribution of teams. The teams are going to work on trying to grow different markets, and we want to make sure that the teams are kind of equally matched. And the scenario is, hey, we don't have the actual teams data yet, so we're going to go out and find some data that's kind of like the data that we're going to get and do some analysis on it in advance. And we're going to use the World Cup, 2018 World Cup data. So the kind of the notebook walks you through it. The World Cup data is here. There's no solution data, or there's no solution notebook here, but we can talk through this one, and I'm curious to see if you all saw similar things, or you know, or different things. The basic steps are first to import your data. So you're reading in your CSV and then doing some like processing on your column names. The data is basically, there are 32 teams, and they're, you know, those 32 teams are distributed into 8 groups of 4. So we've got our data in to a pandas data frame. They tell us to use a subset of the interesting columns. So we create a new data frame with the interesting columns. And then we are creating a new feature or metric called the past performance metric. So basically this is a weighted sum of previous titles, finals, semifinals, and appearances. And then through the rest of the case study, we're doing kind of summarization and exploratory analysis on these, you know, this created metric as well as others you could use. I focused on 2, the current FIFA rank and the past performance as my kind of metrics for, you know, the things that I was curious about to determine whether these groups were evenly matched. So this first block here is just creating this new feature column. That's just the dot product of your X columns that they gave you and the weights. And so you've got this past performance column here. Then they're asking you to do some summaries, knowing that you've got this data where you've got this group column that kind of screams out for some, you know, group bys or pivot tables. And again, I looked at the mean of the rank and the past performance by group. You can plot that. I also looked at some other statistics. You could also do a describe on these to get stats like min and max and mean and standard deviation. I also did some box plots to try to visually show that. And then you're checking for missing data. This is all stuff that we've done in previous modules. There didn't seem to be any missing data in this data set. So you've got your summaries and your visualizations, and now you are being asked to do some hypothesis testing of the kind that we've been discussing. The first step is they ask you to look at, you know, they note that you could use an ANOVA approach where you're getting a p-value for multiple groups, but that ANOVA approach would not tell you which of the teams were different and how many. You wouldn't get a lot of information about that. I ended up doing that anyway just to see what it said. And that is here. Basically just putting the different groups into a list of list by group, and then running the ANOVA, and you get a p-value of 0.73, or I got a p-value of 0.73. So my null hypothesis in this case was that all the groups have the same mean. And this did not suggest that that was unlikely. So then I went on to do the pairwise comparisons. Here I did that just by iterating and looked at the different pairs, and you can see that the p-values differ, but none of them get particularly small. And then you're applying kind of these multiple test adjustments. To do this, I just created another data frame, and through the team pairs, I used a kind of crazy list comprehension in Python to do this, but you could do it just with regular loops. But I threw the team pairs into a column, the unadjusted p-values for that pair into a column, and then the Bonferroni adjusted p-values and the Benjamini, I forget the last name, the BH adjusted p-values into another column. And if I did this correct, the adjusted p-values basically say there's little to no data that suggests that the null hypothesis should be rejected. In other words, it is fully reasonable that all of these groups have kind of the same mean past performance, or in other words, that there's no evidence that the distribution of the teams is unfair. Did anyone get any a different result?
Nope, I got the same.
Okay.
Yep, I was similar.
Cool. Yeah, I did look up. I had to Google, hey, I got all one values, ones with my Bonferroni. Is that unusual? And there is, that question is out there on Stack Overflow, and nope, that seemed to be fine. They do not, like I said, there's no solution here, and they did not, do any analysis, but, it looks like, that this result is, basically we've identified that the groups are fine. And then, going back to the scenario, we could then, once we get our actual avail data, we could apply the same set of methodologies to that data. I did not do anything with the kind of the extra credit here, playing with generalized linear models. Did anyone work on this?
No, I didn't, but looks interesting. Maybe I'll try it next week.
Yeah.
No, I didn't either.
Yeah, I didn't pull this. I didn't pull this one up, but this multi-level modeling thing could be interesting. There's a ton of interesting background reading material here. So if you want to dig into kind of p-hacking and some of the implications there, there are a bunch of links. There are a bunch of links focused on the papers for the Bonferroni and BH are both linked. This multi-level modeling one could be interesting. So, lots of extra credit opportunities here. But this is basically the case study. I thought, for me, it was a useful exercise to kind of put all the pieces together. There's still, I'm definitely going to check out the Cassie Kazarov videos. Those look like they'll be really interesting and kind of filling in some of the statistical gaps. Any other thoughts or comments?
Yeah, I have one there, Sam.
All right.
If I was reading correctly as you were scrolling through, they said that, the case study was to look at how balanced the teams were.
Yep.
And it said that one, you don't have the data yet, so you could come up with like a model based on some other thing that you could then drop the data into when you get the data. You're going to basically reuse the model.
Well, I would say in this case, what we're doing is we're coming up with an approach, not a model.
Okay. Oh, that's fine. But so in that approach that we did, well, with the World Cup teams, you have some very objective measures. You know, wins, losses, appearances. These are all just numbers that exist.
Yeah.
For saying whether or not a team was balanced, I mean, how are you going to apply that kind of logic to a situation where you don't have any of those numbers?
Yeah, I think that, would be an interesting challenge in trying to apply this approach. But the specific example they gave was one where you've got, presumably these marketing teams. The assumption would have to be that you've got these marketing teams that have historically been performing this task of growing the performance of their regions, and you've got historical data on that, and you can come up with a some kind of past performance metric, and you are comparing them based on the past performance. And that raises an interesting point in that all of this analysis that we did was based on what is a fairly arbitrary, or rather completely arbitrary, weighting of
Right.
historical facts, right? It's completely arbitrary. In fact, it said, 16, 8, 4, 1, but pick whatever you want. And, it's potentially a good example of p-hacking, right? Would be, okay, let's pick this, it looks like everything's fair. Maybe we tweak these and we just keep tweaking until we find one that says that it's not fair, right? So that would be your example of p-hacking. I think the kind of the proper statistical application of these techniques demands that we kind of come up with a principled weighting of, principled definition of past performance, and kind of lock that in before we start doing our analysis, and then don't change it afterwards. But I think your point is valid in that, a lot of the work in applying this in a kind of business team type of scenario would go into trying to figure out what that right metric is. If you're trying to balance like sales teams, that might be easier because you've got a sales metric, which is, easily built into a number. It's a number. But for marketing teams, that, could potentially be a challenge depending on what data you have. Totally agree with that. Did that answer your question?
Yeah. You have to. The metric is critical here.
Yeah.
And I didn't really, read it, but it seemed to me the teams were more like kind of. I didn't quite see exactly what the teams were doing, but I thought we were actually looking at the individuals in the teams. So maybe I got that wrong too. But
so in
we're balanced.
Yeah, so in this data, you've got groups and then countries and groups, but you could see, you can imagine in the business scenario, the groups are your teams. Each team has 4 members, and the countries are individuals, and they have some past performance against whatever your business task is.
Yeah, it just comes down to, like you say, this. You have to have a metric, and there has to be some reasonable grounds for the metric, and you can't play with it once you've settled on it.
Yeah, which even knowing that, like, I can see why people get in trouble for p-hacking. Like, the first thing that I wanted to do after I was done with this exercise was play with that weighting and see what happened. And I guess it's fine to play with it, but when you then try to use that to justify some decision, that, that's where you get into trouble.
Okay.
Any other thoughts or comments or discussion around the case study?
But to your comment on p hacking, I think I remember learning always that no matter what, for example, those settings for alpha you have there, no matter what those settings are, you should have a logical reasoning for those settings versus the inverse where you just want to play with to see what gets you the best p-value. Like there should always be a logical reasoning for why the settings are what they are based on some form of qualitative or quantitative observation to justify it.
Yeah.
Right, and you have to set your p-value up front. But this also really underlies some of the really popular exposés of academic research, especially in social science, where they were finding things like you really couldn't replicate a lot of the really famous major studies. And so, I feel like the discipline has really shifted a bit to preferring Bayesian methods. And there have even been some really big statements to that effect because of the incidence of p-hacking and then, also some other kind of downfalls of a traditional statistical approach. And so the shift really has been to look more at the Bayesian methods.
Yeah, no, that's a great comment, and I meant to mention that in the video that I mentioned. I think it's in the video. Maybe not in the video, but in the materials. Okay, it's the reading right after the video. They talk about kind of looking at this through a Bayesian lens as a way to overcome some of these issues. I didn't go through any of this. Jess, are you doing the causality course also?
I did the first round, and I think I got behind with the new job and missed the boat on upgrading to the second round.
Yeah, so we've got in parallel with this another study group going for a causality, basically causal methods in machine learning. What was your experience with the first couple courses? How did you like it?
I liked it a lot. He was going to a really deep level of detail. I thought it was really robust. I mean, it definitely felt like, this is a meaty course, and there was a lot to learn there. And I actually had planned to go to the extended courses and kind of catch myself up, but I think I somehow missed a deadline because by the time I saw it, I read a message saying it was getting cut off tomorrow, which was like the day before I saw the message. So.
But I mean, if you're interested in doing that, I can talk to Robert, or you can reach out to him and see if he can.
Yeah, I may do that. I mean, it's something that really isn't covered, in that level of specific detail often. So I really was enjoying it.
Yeah, and so for the rest of you, keep an eye on the Slack. We don't have any specific plans about kind of a next session for that, but I only attended the first one, but the material is really interesting and it's something that I'm looking forward to digging into at some point. All right, cool. Any other discussion, questions, thoughts, comments? Meta commentary about the structure for this particular session?
Well, I think it probably got people thinking about the overlap between machine learning and statistics. Mm-hmm. And, how there's, a matter of great debate about, is machine learning really, kind of another way of saying statistics, and, or is it really truly different? I think I've seen a lot of interesting kind of discussion on those points, that like a data scientist is kind of a new way of saying statistician, depending on what your work consists of day to day.
Yeah, that's a really interesting point. I think for me, what was kind of interesting was maybe the opposite of that. Like you can do a lot of machine learning without doing a lot of statistics, but you're kind of, to some degree, it's like you're pulling tools off of a shelf and you're not really understanding the foundational things that are making them work. And so this particular exercise and the stuff that was covered in this week of the course, I think was a good, both a good kind of reminder of the importance of, grounding out on those underlying principles, but also a good reminder of some of the, what some of that stuff was for me.
Yeah, exactly. I think there's a lot of statistics, hidden statistics, I think, like in the work that, most of us do if we're kind of dealing with data science or machine learning at all. I think it's just that it's sometimes built into the tool sets, or it's, called something different than it would have been in the traditional field of stats. And but I think it's all there. It's certainly the underpinning. It certainly is something that is central to that kind of work.
Mm-hmm. James, what do you think as a newbie? Still with us or muted?
See, this is what happens with statistic
No,
people
I'm
just
sorry,
fall
I wasn't
asleep.
able to unmute. It was my fault. It was the button. No, I was here the whole time. Oh my God, I learned a ton, and honestly, probably the class is probably over my head, and yet still I learned probably a ton. And so, I'm not sure. I was kind of hoping the class might be Introduction to Data Science AI, and I realized it's more like if you're already a good professional, how can you get better? So I'm not sure it's the right class for me, but it's a fantastic class.
Yeah, I've got mixed thoughts on the class and the background required for it. I think
Okay.
they're certainly making a ton of assumptions about things that and they're marketing the course for experienced data scientists.
Right.
But that said, a lot of the material is, I don't know what the right word for it, basic or element, like there's null hypothesis testing. Like we're not going enough into, so much detail that it can be considered an advanced treatment.
Right.
But it's more kind of grounding on the basics. Now we're only 2 courses into a 6-course series.
Right.
But my sense of it is that, if you've done some basic machine learning courses that kind of focus on models and have a decent understanding of that and are willing to, do kind of extra work or, feel like you kind of don't understand, but you learn something, then it's a fine course to take to complement, more model focused courses.
Yep. I guess I was thinking, and this is like purely my coming to it, there's nothing about the class that was mislabeled, but I was kind of thinking like, what about all those executives and managers out there who have to manage data scientists or work with them actually at this point, and they don't even really know the ideas. And I think it's one of the reasons the companies are struggling to get on board with this is that the managers are so in the dark. And I was kind of thinking, gosh, what if I was one of those managers or just someone who works side by side with a data scientist? How could I work better? And so I wouldn't have to know how to code in Python, for example, or maybe I've never literally done a machine learning model.
Yeah.
But I need to know how to assign or find out when the data scientist comes back to me with a finished, something that's ready for production. How do I evaluate that? Even though I don't know how to do it myself. And it's like, I think there's people like me who want to be educated in that, So I don't know. I'm rambling, but there's just some thoughts at this point.
No, that's great feedback. I don't think that is this course, but
No,
I think that is great feedback. And there's a course in there somewhere that kind of up levels this material to more of an executive level for sure.
Right. And maybe not even literally an executive, maybe someone who works on a colleague by colleague basis with data scientists and AI developers, even someone like, head of sales or even a sales rep, for goodness sakes,
Yeah.
But okay, well, I don't want to be off topic. The funny thing is, even though a lot of it was over my head, I learned a ton, like, oh, wow, that and that and that. Like, so it was like super interesting, even though it was like more down in the weeds than I ever got.
Cool.
Well, I mean, you're making really good points, James, right? So this comes up in terms of those, how you communicate and present results to different audiences, because some people, their eyes are going to glaze over. You start,
Right.
trying to explain things in really, statistical terms, right?
Right.
But at the end of the day, they do want to know, is this accurate? How confident are you? Should I take this forward? I mean, this is like, pretty darn accurate, or it's, maybe not. And so finding that level to communicate with somebody about some of these topics is kind of an art and skill in itself, I think.
Right. Right. Yep. Totally agree.
Yeah,
So-
I agree with that, Jess. I think having worked more in the business world and more on the management side, I did have some statistical courses in business school, so a lot of this isn't foreign. But I think most people, like you said, James, most people like a sales leader would likely not have that background. So I think
Right.
Jess's point is really, really important. Yeah, it's data scientists. I think have to learn a layman's way of presenting statistical insights in a way that's right. Like we are 95% confident something is much more right understandable to someone than we got a p-value less than 0.05 and therefore believe this is the case, right? So I think, and then in terms of, so I agree with Justin. And in terms of your thoughts on how deep the course got into some of the stats, I think there are parts of this course where I feel like I know a lot. There's parts of this course where I feel like I know nothing. But what I think has been helpful, depending on the content, is that for the most part, the links in the curriculum are there. So you can click on whatever it might be and go read more about, whatever it might be, whether it's basic stats at Khan Academy or basic structure around Python programming. Like it's a lot of it's there. So you can still, like, the course is doable. It just requires them digging into what those areas a little bit more.
Right. I think it's one of the sort of interesting things about business going forward and data scientists' role in business is that probably for the first time ever in the history of business, there's going to be a group of workers, a group of professionals that I don't think management is going to know how to manage, in that they so fully do not understand what they're doing. I mean, say there's a factory out there that makes, handmade chairs, and the person who owns that probably couldn't make a great handmade chair, but he's got 6 artisans working for him. He knows how to evaluate the chairs. But I think the managers today are not going to really be able to say, I've got these 5 data scientists working for me. I don't really know. And sometimes they spend a long time in modeling before it even gets to production. I don't know how to really manage these people because I am so in the dark in terms of what they do. So those group of people that are actually not the data scientists, but need to work with the data scientists, need to be educated without going all the way down into the weeds. And Sam, you made the point that's not this course. I realize that totally. And it wasn't labeled as such either. So I have no reason to believe it's a course, but I think that course itself there's a need for that course, as you said, Sam.
Yeah, I mean, I've been privy to many of those conversations where it's sort of like the leveling of the conversation is very awkward,
Right.
Because I've heard people really go off into, and sometimes it's machine learning and sometimes it's statistics or, what have you, at a level that the manager really just is not going to be able to follow that or cares. They just
Right.
want to know, like, how confident can I be in this? Have you accounted for everything? Is this, yes, we should go this direction, or no, we shouldn't? And the explanations that they're able to kind of get to support the decision making that they need to do makes them more confused, right? Like it doesn't
Okay.
it doesn't inspire like if you say, okay, so have we accounted for this and accounted for that? And then you get a response, oh, I did a 3-way ANOVA and I had a p-value of 0.01. So is that a yes, or that's a no, or was
Right.
that, was that really mean, or,
Yeah, right.
and so I think it's, it's definitely, and then when you start talking about things like deep learning or, machine learning as we would really think of it, I think then, yes, for those people in many of the leadership positions, it's such a different world that it's like they have to make decisions based on using those tools or decisions about using those tools, and they don't understand it really well enough to even be doing that. But yet, time marches on and industries march on, and so they just are in that position of doing that anyway. I think I've seen a couple courses come out from Deep Learning AI has something, I think AI for Everybody, that is a bit geared towards the business manager.
Okay.
MIT does one, but again, that's a paid one. That's like a executive education course, and it's something along those lines. And I think I've seen one out of Stanford, but other than that, I don't see a whole lot on that topic. But it's a pretty important gap, right? Because there's a lot of buzz out in the world about how AI projects, are they successful or are they not?
Yep.
And, I do find myself wondering, well, maybe it's not really all the technical people's responsibility, that, whether those projects are successful or not. Where's the managers or the leadership in this, or the executives making decisions in that too? Because if they're making those decisions to fund or not fund things that, or take things forward or continue funding them, and they don't even know what they are really, then that's a different world, I think, than what, how industry is used to functioning.
Yeah, I end up, because I'm a journalist, I end up interviewing a lot of people across the industry, and just in the last literally 30 days, and I won't mention the company names, but I interviewed someone who's the head of a large software company, and she does product evangelism and education. And we were talking about what machine learning is and what AI is. And then I was also, in a separate interview, I was talking to one of the leading executives to a major financial services company, and he was in charge of AI for them, or one of their leading executives. And I was talking to him about, okay, what is AI and what is ML? And those individuals gave starkly different answers to that one fairly straightforward question. And I thought, wow. And they're not even like the sales reps or the non-AI people. These are the people with their hands on the technology, but they themselves have significantly different attitudes towards it. And so, I mean, one of the things I take away from that is that this is a very powerful area, and this area, data science and AI, if it isn't already ruling the world, it's about to rule the world. And yet there is not a lot of understanding about it. It's still a very new area. It's very powerful, but it's very new. So I don't know, we may be off the subject of this course, but those are just my general thoughts. Thanks for listening.
Yeah, I guess regarding the course, my thoughts are that, it seems like it's following kind of the pattern where you're putting in place some basics, and then maybe you're going to take those forward, kind of onto a deeper level, or at least I guess that's what I'm, how I'm looking at it so far.
Yeah, ultimately the goal is to, I think my kind of read on the first few modules, the 4 that we've done thus far, course 1 and course 2, is that they're kind of talking about, hey, you probably, if you have done, if you're doing machine learning, you're a data scientist, or you've learned machine learning, through courses, you've probably seen this stuff before, but if you're going to do it, for real in situations that count, or at like an enterprise scale, you need to think about it a little bit differently. And in the case of the data ingestion stuff, the thinking about it differently was, how do you kind of make data ingestion modular, so you can, do it streaming or, at scale, what have you. In the case of, this section of the course is more about how do you, really think rigorously about the underlying statistical properties that you're dealing with. It's the next one that we talk about is going to be the first part of course 3 is focused on feature engineering. It'll be interesting to see, what they talk about there. I think once we get to, I think it's course 4, or 5 and 6 is when we start talking about like, okay, now you've got these models and you're trying to deploy them into production. What are some of the tools that you use to do that?
Mm-hmm.
I think it's an interesting course so far.
Mm-hmm. I learned a lot just in that 1 hour for sure.
Cool. Vince, how about for you? How's it going?
Yeah, I thought today was really good, but like I haven't gotten to it. But it helped. It was more like focusing on, like I said, the first couple of weeks I just found very abstract, and the discussions were kind of abstract. So that wasn't terribly helpful, and that's why I said that.
Yeah.
But the more it gets into actually, doing stuff, and then I like it a lot more.
Yeah.
So yeah, I think it's trending in the right direction.
Cool. All right. Well, congrats everyone for completing course 2. Next up is again data transformation and feature engineering course 3. Feel free to chime in on Slack as you're working through the course with any issues, or check there as I'm working through it. If I run into any problems like files or whatever, I will mention them there. And looking forward to seeing everyone next week.